about lifting a book and calculating work, it's giving me some trouble. So the question is, how much work is required to lift a 5 kilograms book 2 meters high?
Oh, work problems. I actually like this. So first, what do we know about work?
So work equals 4 times distance, right? So W is equals to F times D.
Yes, but here's where I'm stuck. We have the mass 5 kilograms and the distance 2 meters, but not the force.
Ah, good point. That's because we need to calculate the force first. Remember, force is mass times acceleration. In this case, what is the acceleration?
Okay. It is gravity. So the gravity is 9.8 meter per second squared, right?
Exactly. So the force would be F is equal to M times G is equal to 5 kilogram times 9.8 meter per second squared.
Okay, let me calculate that. 5 times 9.8 is 49 newtons, right?
Yes. So now we have our force 49 newtons and the distance is 2 meters. So work should be
Wait, before you answer, Dominic, do you know why we use 9.8 meter per second squared for gravity?
Because that's the acceleration due to gravity on Earth's surface.
right. And that is important because if we were on the moon, we'd use a different volume. The work would be less there because gravity is weaker.
Good connection, CJ. Now, back to the calculation. So we have 49 N of force over 2 meters.
Okay, let me calculate that. So 49 times 2 is equal to 98. So 98 joules.
Yes. And just to be throughout, why joules?
Because work is energy. And the standard unit of energy is joule, which equals a Newton times a meter.
Okay. So to summarize, first we found that the force using is F equals mg. Then we calculated work using W equals Ft.
And we should mention that this assumes we're lifting the book at constant velocity and no acceleration.
Right. If we were accelerating the book upward, we'd need to account for that extra force.
Good point. Also, does the path matter? Like if we lifted it straight up versus at an angle.
For work calculations, only the vertical distance matters when working against gravity. So the horizontal movement doesn't count here.
Unless there's friction involved. But that's more advanced problem.
Got it. So our final answer is 98 joules. That makes sense now. Thanks for walking me through this topic.
No problem. And just to connect this to real life, this same calculation applies to things like lifting weights and at the gym or hosting construction materials.
Or even carrying your backpack upstairs. The heavier it is or the higher you go, the more work you are doing.
Okay, cool. So we've covered first, calculating force from mass using gravity. Secondly, calculating work from force and distance. Third, the assumptions behind the calculation. And lastly, real-world applications.
Perfect summary. And remember, the units are crucial for mixing up kilograms and Newton, isa common mistakes.
Alright, should we move on to the next problem? Or does any one of you have questions? So I think that's it. That's all.
Right?